Okay, here we're looking at the distance formula on this slide. And this formula is a perfect example of how math looks a lot harder than it really is. Because you look at this and you go like, what the heck is this? You got p's and x's and y's and square roots and squares. And I want you to stop right now, pause the video, and go to where the next slide is and there's actually some numbers. Because this is really not that difficult. All it is substitution. So let's take a pause of the video, go and look through a couple of examples, and then come back and look at this video, and I'm going to do an example for you with numbers. Did you pause? Okay, coming back to this video, what you should have seen is all I'm looking at is a couple of points. P just stands for point. So if I get rid of this, and I just literally say, well, one of the points, the first point is going to be like 7 and a negative 5. And the second point is going to be like, I don't know, maybe we'll pick 4 and 1. Why not 4 and 1? Okay? Just any numbers. Notice I just picked them. There's nothing magical. What this formula is doing is just asking for the distance between 2 points. So if I really quickly, from our plotting points, just do a really rough graph. 7 and negative 5, well, I would go over 7 and I'd go down 5. I'd be somewhere around here. 4 and 1, well, I'd go over 4 and I'd go up 1 and I'd be somewhere around here. And what the question's asking is, how long is this point? What's the distance between these points? So basically the length of the point. So if we get rid of all of this calculation and just say, I want to find the distance. Yes, it's between the 2 points, big deal. I want to find the distance. Okay. And I'm just going to literally sub in the points. Well, if this is the x value of point 2, I go to point 2, I look for the x value, I see it's 4. Then I'm going to subtract the x value of 0.1. Well, I go to 0.1, I look at the x value, and I see it's 7. Same thing, look at the y value of 0.2. I notice it's 1. Minus, I look at the y value of 0.1. Ooh, negative 5. Careful. Because I'm subtracting a negative 5, right? So there's a double negative there. Right? And then it's just simplifying the numbers. I can say, okay, this is square root, yes. 4 minus 7, that is negative 3 squared. Plus, be careful here, 1 minus negative 5. If we have a 1 minus negative 5, so 2 negatives really mean I'm adding. So I end up with 1 plus 5. So I end up with 6 squared. And then I keep working down. The distance is, well, negative 3 squared is 9. Plus 6 squared is 36. It looks like the distance equals the square root of 45. Okay? And I can leave it like that. I can leave it as the square root of 45. Or I can go, if the question says solve it to 1 decimal place, then I'm going to have to go in my calculator to square root of 45, and I'm going to have to end up with a decimal place. Okay? But that's how you solve it. That's a perfectly legitimate answer, unless the question says stated as 1 decimal place or stated as 2 decimal places. Then you actually have to do that square root on the calculator and get that answer. I hope that makes sense.